What's up everyone, the Alchemical Jackalope here, and welcome back to another episode of Possible Science! Yes, I'm actually back doing this again. And what might the topic be? Well, the topic is a question sent in by fellow YouTuber Tenchi Arizona, the angry Dracalope of the Jackalope crew, in which he asks me to actually figure out what happens if you attempt to make an alloy using magnesium, sodium, and lithium. And quite honestly, I had quite a blast with this topic, considering that we're doing two alkali metals and also one that is kind of close to the alkali metal family. So, how is it actually going to go? Well, I'm going to try something really new with this. So, over to my other camera right now. Now, as you might be able to see here, I've written this all down to make it easier to explain. So the first part we have to go through with this is to learn about the relative isotopic mass, which in this case would be grams per mole is equal to U, where U is the relative isotopic mass. So 1 U would be equal to X gram per 1 mole. So, as you might be able to see here, sorry for the very bad quality, but I was not exactly having the easiest time with figuring out the camera. So 1 U of magnesium is equal to 24.305 gram per mole, while 1 U sodium would be equal to 22.99 gram per mole, and 1 U of lithium would be equal to 6.94 gram per mole. Now, as you will be able to see here, once I understand that, I need to bring up oxidation states. Magnesium has +1 and +2, while sodium, sodium have +1 and -1, and the lithium have strictly just +1. So, in normal conditions, we would have that 1 magnesium plus 2 sodium, well, yeah, I already pointed that out, would be equal to 1 disodio magnesium. Then we would have magnesium plus sodium would become monosodio magnesium. And then we have sodium plus lithium, which would be a kind of disturbed alloy that could react really powerfully. Oh, and don't think about those right now. I was thinking I would bring up the size of everything, but I didn't. Now, for this reaction to actually happen, we need to have 2 units of magnesium, or 48.61 gram of magnesium. We would have need of 1 unit of sodium, which is 22.99 grams, and 1 unit of lithium, which is 6.94 gram. And once again, don't bother with the stuff on the left there. As you might be able to see, I was only curious about sizes. Either way, magnesium have a smelt range between 650 to 1091 Celsius, or 1202 to 1994 Fahrenheit. we are the last one is actually the boiling point. So we're having kind of a strict line. Sodium has 98 to 883 Celsius, or 208 to 1622 Fahrenheit. Lithium have 180 to 1330 Celsius, or 356 to 2426 Fahrenheit. This actually leaves us with a working smelt range between 650 to 883 Celsius, or 1202 to 1622 Fahrenheit, which is actually because of sodium's boiling point. However, if you're not doing this in an inert environment or atmosphere, you're gonna have to contend with the oxides: sodium oxide, lithium oxide, and magnesium oxide, as I'm pointing out right here. So we're having, at first, we actually have sodium oxide that is 1132 to 1950 Celsius, or 2097 to 3542 Fahrenheit. And yeah, as I'm quick to point out, because it's not really matter, sodium oxide have a boiling point of 1950 Celsius. Lithium oxide have of 2600 Celsius, but magnesium oxide have a smelting point of 2852 Celsius, meaning that we are going to actually have the sodium oxide itself and the lithium oxide break apart back to their original components, and at that point, well, you are not gonna have a fun time. So, if we actually do it in an inert environment, moving the camera, sorry for the bad quality, either way, we would have 48.61 gram of magnesium, 22.99 gram of sodium, and 6.94 gram of lithium. And this would give us an alloy with the potential mass of 78.54 grams with a density of 1.214 grams per cubic centimeter. And that's actually pretty much everything on that. So back to the normal camera. And we're back. So as you can actually see in this explanation of mine, it's not gonna be the easiest way to actually make an alloy from magnesium, sodium, and lithium, unless you're in an inert atmosphere, which is really hard to actually achieve. But there might be someone out there that can actually do it, because otherwise you're gonna have to really go for a pain with any oxides, and at times perhaps even peroxides, or as they are commonly known, superoxides, and those can be quite dangerous. But anyway, hope you enjoyed this video. If you like it, then give a thumbs up, maybe comment in the comment section below, and maybe subscribe so you can get more videos like this in the future. I'm trying to legit keep up with making videos for all of you beautiful moon beasts, but like everything, I might not be able 100% of the time to actually bring up a topic that, or anything that could be recorded. I can actually admit to that due to a few previous ideas I had that kind of ended up making a certain person consider me stupid if I actually put it up. And looking at it at this point, I have to admit it might actually have been a quite dumb idea. But I do actually have something planned for the next video, which is gonna be another possible science, but at the same time it's also gonna be quite an awareness video on the dangers with a certain reaction that I'm gonna be explaining. So yeah, until next time, the moon may hide a beast in shadow, but it might just be salvation. So see you guys during the next moon phase. I'm the Alchemical Jackalope.
Systems powering down.